So, for those of you that actually came to class, you're going to realize that this is not the problems that we did in class. I had a little bit of trouble with the recording for the class, and that caused a few little issues. So I had to re-record it. That's fine. You're going to get the exact same information. But I am probably going to look at another options instead of using WebEx. We might use Microsoft Teams or Google Meet. I just have to look at those two options because I think the recording feature is a little bit better in those. So went through and did this problem. So I'm actually going to show you the screens. So the first thing we're looking at function problems is it's f of x equals y. X is my input and y is my output. So when they give you the problems in this problem thing, it's going to have the f and then the -3. So that's my input. So I'm going to plug that in to the problem. So I'm looking at the first one, -3. And notice I put it in parentheses, so this way I recognize that that's the number I'm plugging in. And it also takes care of some of my sign issues. So -3 there, -3 plus -3 squared, which gives me -3/6, which is -1/2. So that's f of -3. Same thing for the other two, the g of 2. I'm going to plug into the square root problem right here. So I get 1 plus 5 times 2, which is the square root of 11. And then my final problem is h of 4, and that's the square root, the absolute value problem at the end. -3/2 times 4 minus 10. -3 times over 2 times 4 is -6. Minus 10 is -16. So the absolute value gets rid of the sign, so it's +16 is my answer. When you're doing them, notice that there's there's help for these problems. Now this is a homework assignment, so this is what your reviews for your tests are going to look like, not what your actual topics are going to look like in the problem. However, there are similar buttons. This button's down the bottom is called explain. It'll actually give you an explanation for the problem. These are little examples that'll actually give you a problem that's very similar to it. So if I click this, you'll see here's the example button, and it goes through and shows you those problems there. And you also have videos, the ebook, and the message center. So that's the first problem. The second one is a piecewise function. Now, a piecewise function is similar, except it kind of puts it all together. You're going to look at the domain over here. The x doesn't equal -2, and the x equals -2. That's going to tell you which problem you're going to use. So for this first one, it's h equals -4. That's not -2, so I'm going to use the first part. So I'm going to plug it in to the x. So I get -4 squared, which is 16, times -1/2. So I get -8 plus 4, which is -4. The next one, h is -2. That is -2. So I'm going to use the second line, which in this case is just -3. There's no numbers to plug in at all. My last one, h is of 2. h2 is not -2, so I'm going to use the first one again. So it's -1/2, 2 squared plus 4. -2 squared is 4, times -1/2 is -2, plus 4 is 2. So those are the three answers that I'm going to plug in to this problem. So I have -4, -3, and 2. We hit check on the problem. And then notice also another button that these come up. It says try another one. If you want to try another one of those problems, that's fine. You can try another one of those problems. All right, so the next set of problems is going to look at graphs and pulling information out as well. So again, my function notation is my input and output. So this one says f of 2 equals. That's my x value. So I'm going to look at my x value is 2, and I'm going to find my y value that matches with that. In this case, it's -1. So that's the answer for this one. I'm just going to put in -1. It's only one problem, one little thing that they're asking for in this topic. So if they give you the x, they're looking for the y. If they give you the y, they're looking for the x, which you're going to see in the next problem. So now in this one, there's two questions. The first one says f of x equals 4. So in this case, they're giving you the y value and they want the x value. So I've got the y value is 4, so that means my x value is 0. The next one, they gave you the x value is -2, and they want the y value. So negative 2, my y value is 2. So you look for them both there. And we're going to do one more of these because there's another problem that's they can show up in this topic, and I want to make sure you understand them both. So notice in this one, I'm going to use the try another button. So in this one, I've got f of 1. So they're giving me my x value, and that's right there. My y value in this case is 0. And they tell me that f of x equals 3. So I want my x value. So now here, I have two values that'll work. I've got that one and that one. So I got negative 1 and 2. You can use either one. So I'm going to use the 2. So either one of those points that works, you only have to put one of the two numbers in there for that one. So I'm going to put the 0 and then the 2 for this one. Now this topic, they're asking you for a little bit more information. So the first thing it's saying is f3 negative. So let's look. F of 3, the answer is negative 4. So yes, f of 3 is negative. The next one it says, for which values of x is f of x equal to 0? So we want to know where all the y's are zeros. So in this case, I've got negative 3, I've got 0, and I've got 2. So it's right there, and right there. The last part says, I want to know where the values of x, where it's going to be less than 0. So this one we have to do a little bit of a range for. So, or an interval for. So I've got the values right here, and then I've got the values right here. Those were all the values where it's less than 0. So when I'm writing these, I want to do it in an interval notation. So the first one is going from negative 3 to 0. And I'm going to use a parenthesis. So parenthesis means not equal to. A bracket means equal to. So since I don't want it to be equal to 0, I'm not going to use the bracket. I'm going to use parenthesis. Now this one here, I'm going from 2 to 5. Now 5 does work. So I'm going to put a bracket on 5 because 5 is less than 0, where 2 is exactly 0. So I don't want the 2. I want the numbers right next to the 2. So when I type this answer in to the box, I have to put them both. So you can use the keys on your keyboard. So the negative 3, comma 0, parentheses. The union button's right here, or you can use the buttons actually they gave you. So the 2 and the 5. This top one's asking you for domain and range, but it's giving you a graph for your domain and your range. Domain is your set of inputs, range is your set of outputs. So when I'm looking at my domain, I'm looking at my x values. So I'm looking from here. Now it does them all. All right, so I'm looking for negative 5 to 5. So that's my domain. Negative 5 is a closed dot, so it's a bracket. 5 is an open dot, so it's a parenthesis. So my domain is going to be bracket negative 5 to 5 parenthesis. Now, my range is my y values. So I'm going from my lowest y value to my highest y value. Negative 2 is an open dot, so it's a parenthesis. 2 is a closed dot, so it's a bracket. So my range is parenthesis negative 2 to positive 2, and it's a bracket on positive 2. So bracket parentheses, so we can use the keys here, and you just have to tab, and it puts the comma and everything else for you there. And that one, so -2 to 2. Do be careful on the brackets and the parentheses because it will mark it wrong if they're not right, and you'll have to do more of the topics. When you have a discrete set of points like this, your domain is just a set of values instead of, in your range, it's a set of values instead of an interval. So you're just going to use the set notation, and you're going to type in all the values there. In this case, for my domain, again, I'm only doing the x values. So I've got -4, and then I've got -2, I've got 0, and I've got 4. My range, I'm only looking at the y values. So I've got -4, -2, 2, and 4. If a number repeats itself, you do not have to put it more than once, and you do not have to necessarily put them in order for a set of points. You can actually put them in any order you want. It'll still work. All right, in this one, we have a split graph. So it's a non-continuous graph. That's okay. We're still going to do the domain and the range the same way. So when we're looking at the domain, I'm going to look at the two separate points. So I'm looking from -5 to -2, and from 1 to 4. So my domain, since it has those two, this one over here, it's a parenthesis, and then a parenthesis because they're both open dots. So I've got parenthesis -5 to -2, close parenthesis. Then I have a union because I have a second one, and it's going from 1, which is a parenthesis, to 4, which is a bracket. So it's going to be parenthesis 1 to 4 bracket. That's my domain. Now, the range is from the bottom to the top. Now, if I look at this one from the bottom to the top, it doesn't actually break. It starts off at -4, and it goes all the way up to 3. There's no break in it, so I only have one. At -4, it's a parenthesis because it's an open dot, and at 3, it's a parenthesis because it's a closed dot. Even though they're not in the same one, I'm looking at the graph as a complete piece. So, and all the points from -4 to 3 have a y value, so that's why I can do that. So my range is going to be -4 to 3, and they'll both be parentheses. So put those in. So I've got -5, -2, and then union 1, 4. And then my range, I just have 1, and it's -4 to 3. This one, it's a quadratic function, so it's a parabola. In a quadratic function, your domain will be always all real numbers. Notice how there's arrows down here now instead of points? That means those lines go on forever. So I'm going to use my domain is -infinity to infinity. My range, however, has an endpoint. So in this problem, it's starting off at -infinity. So that's a parenthesis because infinities never are brackets. And it's going all the way up to the vertex, which in this case is 4. And then that would be a bracket next to that one. So my range is from -infinity all the way up to 4. If it was going the other direction, it would have been my vertex going up. So if this was going up here, it would have been 4 to infinity. Would have been the only change. The domain actually doesn't change in this case. The domain is always -infinity to positive infinity. Okay, the next 5 problems are all going to be evaluating the domains. So when we're looking at the domains, there's 3 domain restrictions that we're going to be focused on. The first one is you cannot divide by 0. So you cannot divide by 0. The second one is I cannot take an even root of a negative number. So no negative numbers. And the third one, which we're not going to deal with right now, is any real life examples. So example, you can't have a negative volume. So mathematically, I can come up with a negative volume, but it wouldn't make much sense. Same thing, like you can't have negative distances and stuff like that. It's always going to be positive in those situations. So those are the 3 domain restrictions. The first 2 are what we're really going to focus on in the next 5 problems. So this one, I have a division. So I've got x squared minus 4, and that cannot equal 0. So now, to do this one, basically we can just solve this one for 0. So it's because we don't really have to factor this one. So I have x squared cannot equal 4, and I take the square root of both sides. So x cannot equal plus or minus 2. Remember, when you're doing this, when you're taking the square root of something, a positive and a negative version both works. So in this case, I have 2 answers. I have negative 2 and positive 2. And there's no plus or minus key, so you do have to type them both in. I'm going to do one more of these because there's one other problem that can come up. So now this one, same concept. We're not looking at the top at all, because when we're looking for domain, all I really care about is the restrictions. And in this case, the only restrictions are on the bottom. So I've got x squared plus 15x plus 54 cannot equal 0. So now you have to factor. I would get into the practice of factoring these and not using the quadratic formula, just because there's a ton of these problems that are going to come up. And if you can't remember how to factor, you're going to cause yourself a lot of trouble later on. So this one, we're looking for 2 numbers that multiply to 54 and add to 15, which happen to be 9 and 6. So then we're going to set each of those equal to 0. So x plus 9 does not equal 0. X plus 6 does not equal 0. So x cannot equal negative 9, and x cannot equal negative 6. So those are my 2 answers. I will tell you, if you do this really quickly, you are going to forget to do this final step here and change the signs and get the answer wrong. I typically see that on the last problem when people are working on this topic, because they go, oh, I know what I'm doing, and you forget to do that last step. So just be careful. Otherwise, it's going to make you do more problems. And you don't want to have to do more problems. So it's negative 9 and negative 6. This one's the same thing. There's just 2 of them. It's the exact same concept. They just get a little bit longer. So I've got the x squared minus 8x minus 9. Actually, I'm going to do this one, and I want to see, because there's one other problem that's similar to this one. And since we just did that one, I want to try another one. Good. So in this one, I've got the x plus 7 does not equal 0. So I don't really have to do any work. This is just x does not equal negative 7. And I got x squared minus 9 does not equal 0, which we've already done. So I'm going to actually make, so we know this one is going to be x cannot equal plus or minus 3. But I want to show you one other one that can come up because it's very important. Let's say I had x squared plus 9 does not equal 0. I would get x squared does not equal negative 9. Remember, I cannot do the square root of a negative number. So this problem, there is no restrictions. If you were to solve it out, you'd get an imaginary number. And in this problem, we're just looking for real answers, so I don't want the imaginary numbers. It does want it in interval notation, however. So when we're listing these problems out, so this x does not equal negative 7, I have to list this as negative infinity to negative 7, union negative 7 to infinity. So you have to write it completely out like that. The plus or minus 3, I have to write as negative infinity to negative 3, union negative 3 to 3, union 3 to infinity. So I'm going to have both of those there. So it's the way you have to write it so that this way you're not including that negative 3 and that 3. Notice there's no brackets around them, so it's going to that point but not including that point. So you do have to write it out a little differently than the other one. So I've got negative infinity to negative 7, union negative 7 to infinity. And this one I'm going to actually have two of them. So I've got negative infinity to negative 3, negative 3, 3, 3 to infinity. Next problem is a radical, so it's just the square root of x minus 3. Now this one, remember, I have the x minus the 3 is inside the square root. That has to be greater than or equal to 0 because I don't want it to be negative. So I don't even have to worry about the square root. I'm literally just looking at inside of it because I'm trying to find those domain restrictions. So this problem is x is greater than or equal to 3. So when I write this in interval notation, I'm going to have a bracket at 3, and it's going to go all the way to infinity with the parenthesis. So it's 3 to infinity. This one's very similar, so we're going to do the same thing. So I have 27 minus 9x, and that's got to be greater than or equal to 0, because again, I don't want a negative number. So let's solve this one. I got negative 9x is greater than or equal to negative 27. Divide by negative 9. There's a reason I'm showing you that, because when you divide or multiply by a negative, this inequality sign switches direction. And that's very important. Do not forget to do that. Otherwise, you're going to get the wrong answer. So remember, multiply or divide by a negative, the inequality sign switches. So this problem is negative infinity to 3 with the bracket. The last one of these is basically a combination of the two parts. So I've got the square root of x plus 2 on the top and then the 3x minus 6 on the bottom. So I'm going to take the top. We'll do the top first. So I have x plus 2 is greater than or equal to 0. So x is greater than or equal to negative 2. So that's the top. And now I'm going to do the bottom. So 3x minus 6 cannot equal 0. So 3x cannot equal 6. So x cannot equal 2. So that's the bottom. I have to put these two together. So the first one is all the numbers from negative 2 to infinity. And this one says that 2 doesn't work. So I don't want to go all the way to infinity. I want to go just to 2. And then I want to go from 2 to infinity. So I have to cut that 2 out of the first one. So that's how I'd actually write my answer for this problem. Because I have to combine the two domains. So I'd just come up with one domain in the problem. So we have the union. Let's see. So I've got negative 2 to 2 and then 2 to infinity. All right. The last problem is one of those little oddball topics that's in the first section. I think this part of this had to do with a lot just messing up the square root. So the distance formula is x2 minus x1 squared plus y2 minus y1 squared. So my points in this problem, I've got negative 8, 9, and negative 1, 4. So I'm just going to plug those in. So I've got negative 8 minus negative 1 squared plus 9 minus 4 squared So we've got negative 7 squared plus 5 squared. So 49 plus 25 is 74, and it's the square root of that. So the answer to this one is the square root of 74. So in the box, I'm just going to do the square root of 74. Normally, this recording would have been done during the class, and I'm going to hopefully have that solved for Wednesday. So you would have actually gotten a lot of the interaction from the actual students in the class. However, if you do have any questions on these topics, do feel free to send me an email and just ask me questions and stuff like that, and I will definitely go through those. I will have the topic list for Wednesday's class posted tomorrow, so you'll see which topics I'm going to be covering on Wednesday. It'll be another set of them from section 1 in 5 dash or chapters 1 through 5. I'm basically covering all the topics that more than half the class did not master on the initial test or have not done. And that's what I'm going to use going forward. So if the majority of the class needs it, I'm going to cover it. That does not mean that every topic I'm going to cover until we get to chapter 6 and on. And then I will do every single topic, even if people have mastered those previously. So if you do have questions, feel free to email me. I do get back pretty quickly as long as it's during the normal hours. And I'm awake. And I will see you guys on Wednesday.